Hey everyone, how are you all this morning? Woo! Oh my God, energy, strong energy here at the IPFS Connect. My name's Hannah, and I want to talk to you all about how we build IPFS systems that actually work. I've been working on IPFS systems I've been working on IPFS for about 5 years. This talk is sort of like my attempt to share what I've learned along the way. Sometimes these lessons that I think I maybe have learned are a bit painful. So maybe this talk will help you avoid some of that pain by sticking to best practices. All right, so strap in. It's going to be an adventure. Part one, the dream. So how did we get here? Why are we all stressing ourselves out trying to make the whole internet use content addressing? Actually, first, how did you all get here? Why do you work on IPFS? No, seriously, why do you work on IPFS? Tell me. I'm going to actually ask 2 people in the audience to raise your hand and tell the whole audience why you work on IPFS. One over there. Yes. Who are you? I don't recognize you.
Hi. So as I said at the beginning, I want to have any human on the planet to be able to put content online effectively for free, effectively forever.
That is pretty awesome. One more. I know a lot of you guys are working on IPFS right now. Tell me. I should have brought candy bars. I will bring candy bars next time.
Yeah, we got here because content addressing seems like a really great idea, and we would like to roll that up.
Yeah, content addressing, looking up stuff by immutable, verifiable addresses that can enable us to know we got the right content, whether or not it is, no matter who it's from. That's pretty cool. Well, let me tell you, I know how I got here, and I want to show you some of my elite programming and research career that helped prepare me for IPFS. So first of all, I shipped a kick-ass inventory system to help the Gap send khakis to the world, right? Yes. I also shipped a kick-ass loan qualification app for our Wall Street friends over at Moody's, who somewhat famously rated all the mortgage-backed securities AAA. I killed it working on a website for a lesser-known Invisalign alternative, so that was pretty key. And I made the world a better place, and I made it a better place through an ESG investment platform for the young, liberal, and rich. And I worked on failed startups. Lots and lots of failed startups. Okay, but somewhere along the line, in my case, around about 2017, I was inspired. Like I imagine, as we just heard, a lot of you guys were inspired. Bizarrely, to me, this inspiration is captured pretty well on a TV show, Silicon Valley, and I'd like to play it for you. So let's see if this works. Oh, even better.
You've got unlimited time and resources. You can build anything in the world you want with your compression, anything at all. What's it going to be? 3, 2, 1, go.
No, I don't.
Go.
You said I have unlimited time.
Now.
A new internet.
What? Why?
Okay, well, I haven't really thought this through, so... Okay. I own a telescope.
Of course you do.
And I brought it out one night to look at the full moon.
Of course you did.
And I got to thinking, wow, we put a man on the moon using the computing power of a handheld calculator. And then I thought, okay, there's literally millions of times more computing power in my phone, and that's just sitting in my pocket, doing nothing, right? So then I thought, there's, what, billions of phones all around the world with the same computing power, just sitting in people's pockets. So then I thought, what if we use all those phones to build a massive network? And here's the kicker. We use my compression algorithm to make everything small and efficient, to move things around, and if we could do it, we could build a completely decentralized version of our current internet with no firewalls, no tolls, no government regulation, no spying. Information would be totally free in every sense of the word.
You want to build a new internet.
Yes.
Richard, I like it. That I would.
Okay. Oh, it cuts off because there's literally no other part of this clip that I can play in a public audience. But if you want a hell of a laugh, I highly recommend going to look that clip up on the internet. It is freaking hilarious. But yeah, a new internet, right? Like something meaningful, something that like actually makes the world a better place, not just the slogan. Something we'd want our names attached to forever, right? So a lot of us set out building a new internet, and we built like a lot of things. We built IPFS. We came up with SIDS and libp2p and UnixFS and CAR and BitSwap and IPNS. And actually, each one of these is like a huge new specification and project. Like all of that is in IPLD. Yeah? Okay, wait. Then all of this is in libp2p. Yeah? Pretty amazing. Like lots of stuff. Wait, actually, SID is like 4 technologies alone. Just SID. Plus, then if you're in Go, here's some like storage stuff we built. We built like, since you want to talk HTTP, we built 4 different types of HTTP gateways. And then there's like the services you got to build, pinning, providing. Heck, we actually built an entire Go module system at one point. Anybody remember GX? Am I really old? Okay, cool. Yeah, so, I'm part of the story too, because I wrote a bunch of this stuff. This is an abbreviated, like semi-accurate list of things I can point to and say, yeah, that was me, I did that. Yay, woohoo, woohoo. But yeah, here's the thing. We built all this, and like it works, like kind of. I mean, like sorta, which is to say not very much. We're getting there. So we have like all that stuff. Oh, I forgot to mention that this thing. Sorry, I just need to make this point. All of this, like super easy to learn as a new developer, right? Just a few things to pick up. I remember when I first started working on this, like the thing that shocked me was like the entire stack was built from scratch. Every single part of it was custom. It's kind of overwhelming. Anyway, cool. So if our protocols are struggling a bit, what are the protocols we're trying to replace? So these are the core protocols of the web, 4 of them, I think. You can run a web browser and a web server with just these 4. Am I wrong? I don't know. Maybe talk to me after if I've forgotten something critical. It seems simple, and like we have so many more names, right? So why haven't we won yet? Well, I would argue that we try to build an internet with protocols. And in fact, the company that even started a lot of this is called Protocol Labs. But the internet is not protocols. The internet is infrastructure, built infrastructure, like a whole lot of infrastructure. Part 2, trains. So if you don't mind, I'd like to take a brief detour and talk about another kind of infrastructure. Let's talk about building trains. The subway and light rail of a major American city. Anyone want to guess which one? Oh, how did you know that? Jesus. That is a major, awesome light rail system that looks pretty extensive, and it's in Los Angeles. Los Angeles has a pretty freaking large rail network, and we're building, like a lot. Everyone thinks we love our cars, but we pay a full cent of sales tax to build new trains. And that's a tax that we voted for. 2/3 of the city voted for to get a new tax pass so that we could build more trains. Which shows you that LA people believe in transit, but we don't actually use it. 73% of Angelenos drive alone to work, and 6.8% utilize public transit. So why? Well, for starters, we already have this. That's the LA roads. There are a lot of them. And once you build something, it's hard to do something different. Our roads cost a lot of money to maintain. Like that sales tax is really great, but about 1/3 of it, as much as the rail, goes to highway construction and maintenance. And geographically, LA is a huge city. The rail network you saw might look pretty big, but it's not when you consider the number of square miles involved. Eventually we'll see buildings start to happen around these lines, but the city is already built. Nobody put the hotspots near the rails. And in fact, those are the places that it's hardest to build because the hotspot people don't like new construction interrupting their hotspots. So you realize that a typical distance from and to a rail stop is on the order of like miles. And everyone has cars. So you can take a rail stop, you can drive 15 minutes to take a 30-minute rail, to take another 15-minute Uber to get where you're going, or you can take 30 minutes in a car, sometimes 45 with traffic. And it's not just the infrastructure, there's the infrastructure of culture. Like, we are known for our love of cars in Los Angeles. And there's a history to that, but that's where we are today. So, what lessons can we learn? First of all, it is harder to build, it's harder to change infrastructure than to build it for the first time. Infrastructure is not just what's built, it's what's built around it. And finally, infrastructure is habits and culture as well. Cool? All right, I just want to do one more rail thing, and then we'll move on. One more bit about trains. This is China's high-speed rail network. If you want to spend an interesting hour, just do a deep dive on this. China has built 40,000 kilometers of high-speed rail. That's larger than all the high-speed rail networks in the world combined. It transports about 2 million passengers a day at about 350 kilometers per hour. It's wild, and it's been built in less than 2 decades. Like, at the beginning of the 2000s, there was none of this, and now it is there. This is California high-speed rail. We approved it in California about 2 decades ago. It's not operational. It won't be done for real for at least a decade, probably more. When finished, it will move riders most of the way between Los Angeles and San Francisco at speeds of less than 200 kilometers per hour. So why is it different? Is it just, further evidence that America is a dying empire and its people have no shared purpose, or some, meta existential thing like that? Well, look, Americans have built stuff. Like, that's our interstate highway system, which is actually larger than the Chinese high-speed rail system. And it was also built in just a couple decades, right? So we can build. But I think there's some more, here's 2 real reasons why I think this happens. First of all, there's a demand, right? And an incentive. Before high-speed rail, China didn't have infrastructure that scaled to its population, or transportation infrastructure. The high-speed rail is like an integral part of China's emergence as an economic superpower. So the system itself is super expensive to build, and it operates at a net loss. But when you factor in like the way it's changed the economy, it's an amazing rate of return. Something like somebody estimated about 6% annually. The system connects China's cities to the rural community so the rural folks can get into the cities, and it's enabled all these smaller cities to become economic hubs to rival the larger ones, because now there's a quick way to move between them. In the time it was built, almost half of China's population entered what economists call the middle income, sometimes called middle class, but I think probably not quite what we think of as middle class, but still, it's 1 billion people. It's like astonishing, right? US, on the other hand, has a road system. It has an air travel system. The California high-speed rail isn't built, will still be a huge economy, right? So infrastructure gets built when there's a need. And there's one other thing we have in California. We have bureaucracy. So if you do a deep dive on California high-speed rail, you will find that there's a few communities and a few local politicians managed to totally mess the whole project up by acting in very, very specific self-interests, either by not allowing the rail to go through their community where it clearly needed to go, or by demanding the rail go to their not very important community, mostly politicians, so that they could get, they could say, I brought the rail to our town. So yeah, there's that. So what we can get is that infrastructure is not just building objects, it's building consensus. Yeah? Meanwhile, China has the central government has basically been able to mandate this and move through. And that's not necessarily great. Similar to the US interstate highway system, right? If you go into the history of these things, they got built fast, and a lot of communities got messed up in the process, A lot of people got hurt in the process. So it's not to say that the one is better or worse, but you have to have consensus to move forward, and that's an important part of infrastructure. Okay. Part 3, building blocks. So, what's the infrastructure of the internet? Well, for starters, it's a lot of computers and servers. There's a lot of switches and routers. This is a Verizon switch center. It's a hell of a lot of high bandwidth trunks. Literally trunks that are ironically a series of tubes. Al Gore was right. We have built a lot of tubes, and that is the internet. Those are some that go underneath the ocean. And if we take what we learned from trains, it's not just what we built, it's what we built around it. It's browsers, which are like highly complex, highly optimized software for reading the internet as a client. And it's web software like Apache and Nginx, a highly optimized software to serve the internet. And then it's not just that, it's standards bodies. It's like the W3D, W3C, standards bodies that now have very vested interests involved. And finally, it's design philosophies. Mostly this guy's ideas. That's Roy Fielding, the creator of the REST architecture, which for many years I sort of like derided as theoretical mumbo jumbo, but it's actually the entire caching strategy of the internet. It's pretty awesome. It's basically what allows the thing to grow to be, web scale. So what do we got? So this is actually the part where I say we do have some infrastructure. Like, let's talk about what we got. Well, for one, we have 250,000 IPFS nodes. That's not nothing, right? We have, through Filecoin, we've actually built a ton of storage capacity. Like, we have a few exabytes of hard drives available that we could be using in some fashion. We have hundreds of us. Well, yes, hundreds of us here in Istanbul trying to build this, right? And we built community around it, and that's infrastructure, yeah? We have billions of dollars of investment that we have spent, sometimes not as wisely as we could have, but some other times, yes. And finally, we have 10 implementations of IPFS. So like, that's awesome, right? It seems like, so we've got a lot of building blocks, right? Oh wait, did we get one more thing? Oh yeah, we're even interplanetary, right? We have IPFS in space. But in any case, we've got a lot of infrastructure. The big thing is, what we don't have, that the web has, is a set of technologies that go together, right? So that people can build amazing applications on top of it, right? The things that the web has all work together such that people build things like Facebook and, I'm not going to go, Google, whatnot, that drive adoption of billions of people. And we need these things so that billions of regular people will start to use IPFS oftentimes without even knowing it. And for that, I want to put out a controversial idea. We don't actually need more technologies. What we really want is fewer technologies, but it should be tech that goes great together. Part 4, systems. So recently I saw a video from Brendan, who I think was the previous speaker, talking about IRO as an IPFS system. And I called him up afterwards, and we ended up having a debate because I was like, IRO is not an IPFS system, it's an IPFS implementation. And he argued that IPFS was not an implementation because it doesn't interoperate with Kubo. And I argued that, well, that's not what the specs say. We made them really open, so you don't have to interoperate. And we went back and forth for a bit, but then I started thinking about, wondering about systems, right? What IRO is a cherry-picked set of IPFS technologies, some old, many very new, that go together to form what I imagine Brendan is busy telling folks in the other room right now is a great platform to build on. So maybe what we need is not implementations, but systems, ways of putting the pieces together that enable highly scalable applications. And that gets to the core point of this talk. What IPFS systems have been built that you can really build amazing applications on top of. So, welcome to the Developer Love section of the talk. I'm doing free advertising for your company for most of the rest of this. but we're going to look at some systems. Let's start with the one we were just talking about, IRO. So IRO is it's a very optimized software, right? It's written in Rust with an eye towards mobile, running on mobile. It has very limited data transfer and hashing. There's only one way to transfer data, and there's only one way to hash it. And they custom select it to work really well. It also has a very fixed network stack. It doesn't use libp2p, it just uses quick. The focus of IRO is to move and sync bytes and also collections of bytes, or like basically like a key value store of bytes. And that's it. And what you get for all of this is hopefully Brandon convinced all of you that they've built a really amazing and scalable syncing platform for files that you could use for all kinds of stuff. You know, like it's almost like a Firebase alternative. It's not an app, it's a platform, but it works, right? I want to talk about another platform. Next thing I want to talk about, UCAN. So UCAN was developed originally at Fission, the folks who I think are the lead putter honors of this conference. And it was built out a lot also by Web3 storage. And what it is a system for essentially tracking chain of authority across an IPFS network, right? At its heart, UCAN is a simple JWT extension that essentially enables verifiable delegated authorization. It means a user can delegate some authority over their data to, oh, sorry, let me get this. Yes. It means a user can delegate some authority over their data to external parties, but in a limited and scoped way. It's like OAuth 2, but simpler. But it's kind of gone a step farther and built this whole concept of delegated invocation, the ability of users to allow services to run things for them, and then to actually get receipts that it was completed. And what you end up with is something really important. There's one more technology in the mix called DIDs, and when you mix them with UCAN, you get what Web3 storage has essentially built. You have the ability to hire arbitrary services to do work for you on the decentralized web. That's wild. Like, I looked at did a deep dive into their technology, and I kept saying, where is your user database? And the actual reality is in their new platform, they don't have one, because the whole thing is delegated authorization starting right on the user's computer. And that's pretty amazing. Let me tell you about one more that I like. They're not here, but Banyan. Banyan is a platform for enterprise storage. But what it really is another technology from Fission, WinFS. WinFS used to encrypt user data, pack it, and set it up to be stored in large quantities. And all of that happens on the user's computer, so it's all private. And then they use a storage technology. In this case, they're actually just using Filecoin, right? To hold all the data, but they need to take it a step further because they want to offer a sort of like, you know, great DX web UX experience. So they have custom storage software that they make their SPs run, and to make their SPs run that software and do a good job, all the SPs have to sign contracts with them. It's not just everybody gets to sign up, but the cool thing is, I think that they have built, or they're building, an enterprise grade working private storage system. It's pretty awesome. So finally, I want to tell you one more. This is a preview of the next talk, and it's also a shameless advertisement for something I work on. Yeah. So the last one is Saturn, right? Saturn is a decentralized content delivery network. And it builds using a combination of technologies, right? We use content addressing, that's IPFS, but we use it for a specific purpose because it actually unlocks a kind of a superpower for us, which is how I hope we think of content addressing. How can we actually use it to unlock amazing benefits for our users? We use, in Saturn, is an optimized IPFS fetching software. All it does is retrieve content from IPFS and do it the best ways we know possible. That runs inside of each Saturn server node. And then in the browser, we run some JS service workers to decrypt, no, not decrypt, wow, I wrote this at the very end, to verify IPFS content, not decrypt, no encryption involved, in the browser, so that the client software does not have to trust the server software. And then we have a crypto-economic model, a simple one, based on metrics, reconciliation, and between clients and servers. It actually does have orchestration software that is centralized to basically do all the fraud detection on those metrics. But what does all this unlock? You'll hear a lot about this in a second, but we've been managed to spin up a massive network of nodes in a short time that offer huge amounts of capacity and have served, a billion requests in a week. And that all is done because the network is decentralized and because content addressing allows us to build a network where we don't have to be the ones running the servers. So you'll hear more about that, so I'm not going to talk anymore. You probably are asking, maybe there's some downsides that are creeping in your head about these systems, and I don't know how I feel about this. Why are you starting to centralize? Uh-oh. Hey, these don't interoperate completely. Okay, there are trade-offs. There are trade-offs in these systems. Yeah, we're going to have to figure this out. And we also have to figure this out, and we have to stay focused on where we're trying to get, not just stop when we get something that works and gets a little traction. We do need to keep moving towards what we want to build. So how are we going to do that? Part 5, people. So this is just, this stuff is hard. There are trade-offs. Some of them are painful. So what do we need as a community to move forward? I'm going to just offer 3 things. First is humility. This is the one that I learned the hardest way. Yeah, we don't know what we're doing. None of us do. I don't know. Maybe some of you do, and if you're smart, like if you're one of those people, like congratulations to you that you have the vision, and then you can just see the future and go towards it. I'm not one of those people. Probably a lot of us aren't. And it's best to just acknowledge that. We're trying to figure stuff out. We don't have to claim it's all working right this second, as long as we're committed to making it work. The other one that I would encourage, and I've seen this across all of our teams, is that we have a culture of competition rather than a culture of listening. We all want to prove that we alone have the big fix, the set of cool things we can put together that will make our stuff, work awesome. And I don't think that's helpful. I just wish we would just take a minute, even the people who are doing the best stuff, take a minute and listen to what other people are doing and just be open-minded about it. Maybe there's something, yeah? And then, of course, the last thing is just a little bit of patience, or a lot of patience. This is hard work. We're doing it together. And a little bit of trust for each other. We all have very strong intentions being here, right? Most of us, or a lot of us, could have jobs that were probably easier, potentially better compensating in, big tech companies doing traditional stuff. But we're all here because we're trying. And so I would encourage, assume positive intent, assume best intent, just trust each other. Try to trust each other, which is hard. That's it. Lastly, just that's my contact information. These are some people and dogs who are very important in my life, make it happy. That's Elaine and my dog, Sadie. And then that's my contact info. And that's the Saturn link. So that's all I got.
Thank you so much, Hannah. That's an amazing talk. I'm glad we got it on video. And I was tearing up at parts of it, seriously, including all the stuff that we've done. And I'm really glad that we've captured this. And, IPFS Connect, let's humility, listen, work together. Thank you so much.